Hello, welcome back. We're going to finally solve a real problem when it comes to prediction intervals. And as I said, we're going to be using the same example a lot. So here we have the age of a home and the repairs per year here, the raw data that we have. And I've put obviously some screenshots from the calculations we've done in the past because I don't want to continue to do them over and over again. But what we want to do in this problem is we want to calculate a prediction interval at a 95% confidence for the population, what they would answer for an 8-year-old home. This is what we've been talking about in the last section over and over again. So if you look at our chart here, here's 7-year-old home, 9-year-old home. 8-year-old home is right here, and we actually have a data point for 8-year-old home. If you really look, here's 8-year-old home. We say that it's 3.7 repairs per year. So then you might ask yourself, well, why are we making a prediction? Why are we making a prediction interval for an 8-year-old house if we already know what the data is for an 8-year-old house? That is something I'm really trying to drill over and over again in your mind. This data is just sample data. It's probably coming from 10 or 20 or 100 homes. We might have averaged something to get this number here, but it's not going to be the population of all the houses in the country. What you're doing with a prediction interval is you're trying to figure out what everyone's answer would be with 95% level of confidence, based on basically this small amount of data that we have in the regression line that we've calculated. So yes, at 8, we see that the answer is 3.7, and hopefully our prediction interval, will obviously be centered around that. We're going to talk about that in just a second. But what we're trying to do is figure out what interval will everyone answer if we could know the population of everybody with 95% level of confidence. All right. So the first thing is I'm putting all this on the screen because we found the regression line already. So I'm going to write some of this down as we go, and we're going to do this calculation start to finish. The regression line, y hat, which is already printed right here on the screen, is 0.865 times x, which is the age of the home in years, minus 3.811. This is exactly what Excel put. It's just flipped. No, it's not actually flipped backwards. It's the way it's written down here. But you have the slope minus the y-intercept. You might see in your book sometimes things are flipped around. They put the y-intercept first and then the slope. That's fine, however you want to do it. But when you're constructing a prediction interval, you have to start somewhere. You have to have a point estimate. That point estimate always comes from the regression line that you have. So and you don't use the data point that you have, you use the regression line, right? So you don't want to use this value of 3.7 as your point estimate. You want to plug in the value of 8 years here and calculate what the line is telling you to do. So for the point estimate for the interval that we're trying to calculate, you do it as follows. You say y hat, which is the value on that line, is 0.865 times 8 years old, that's what we were saying here, minus 3.811, right? The y-intercept. So the value that we get for the center point, the center of the prediction interval, which is the point estimate, is going to be equal to 3.109 repairs per year. All right, and this is supposed to be an I, repairs per year. So the whole reason that we calculate this is because it's going to end up being the point estimate, the center of our prediction interval that we're going to formulate. So far, things are pretty simple. All you do is you use your regression line, plug in the value that you want, boom, that should form the center of your prediction interval that we have. All right, so speaking of which, the prediction interval itself, I'm going to call it prediction interval, is basically going to say that there's going to be some value